The topic of UFO disclosure is gaining momentum fast, with the Department of War releasing previously classified information under the direction of US President Donald J. Trump, and a number of disclosure documentaries featuring members of Congress and scientists has seen the light of day, as well as the upcoming highly anticipated film by Steven Spielberg, Disclosure Day. The question of whether we're alone in the universe is probably the most asked question when it comes to the subject of UAP, UFO and ET research and disclosure. Evidence suggests that there may be some kind of non-earthly, highly technological presence here on Earth and in our solar system, specifically on the Moon and Mars. Joining me today to discuss this and much more is Dr. Maaneli Max Derakhshani, theoretical physicist and philosopher of physics with a PhD in the foundations of physics from the Utrecht University in the Netherlands, member of the Bell Institute for the Foundations of Physics, member of the Foundational Questions Institute, Scientific Coalition for UAP Studies, and the Society of Planetary SETI Research. His research interests include various aspects of quantum physics, general relativity, quantum gravity, statistical physics, philosophy of science, and the study of UAPs and scientific research for the identification of extraterrestrial structures on the Moon and Mars. He is a frequent guest on the news station with special correspondent Ross Coulthard, in which he discusses various topics in the field of disclosure. Today, Max is talking to us about Dr. Mark Carlatto's research, in particular mathematical imaging processing methods for the identification of artificial structures on the Moon and Mars. We also discuss anomalies on Mars's moon Phobos, astronaut Buzz Aldrin's previous comments about Phobos, and a new proposed mission to Phobos. Finally, we'll talk about potential UAP-UFO activity spotted in previous NASA STS Shuttle mission videos. Welcome, Max. Glad you could join me.
Thank you for having me, Jean. It's an honor. I'm a great admirer of your work, and it's been, great pleasure to get to know you over the past few months and to start working together on certain things.
Our collaboration's been awesome. Thank you for that as well, Max. What do you want to start with? Do you want to start with Dr. Mark Carlatto's research?
So I thought just before discussing Mark's research, I would motivate things by presenting a couple of quotes from Carl Sagan, the famed astrophysicist, about the plausibility of extraterrestrial visitations of the Earth in the past, and also general criteria that he devised for how we might identify the technology of an intelligence on the surface of a planet, and then how that connects naturally into Carlatto's work. And it turns out there is actually an interesting connection between Sagan and Carlatto, because they actually had some multiple personal correspondences, sharing some of their work with each other, and it's quite interesting, I think, to see that sort of connection.
That's intriguing.
So then what I'll do is begin by sharing my screen. I'm going to expand this fully.
Right.
Does this look okay on your end?
Yes, looking perfect. Thanks, Max.
Excellent. Okay, so I made a few slides here, which I've used in my presentations for Ross Coulthard's show in the past. This presentation focuses on the question of why we might think that there is extraterrestrial technology on the Moon, but the considerations here can also be applied to Mars, as I'll explain. So to start off, this is Carl Sagan, one of his, I guess, images from the Cosmos series.
Yep.
Many people don't know that he published a paper in 1963 called Direct Contact Among Galactic Civilizations by Relativistic Interstellar Spaceflight, and he published it in a very mainstream planetary and space science journal called Planetary and Space Science. And he basically considers, he uses Drake's equation plus general physical considerations to argue that interstellar relativistic spaceflight would be feasible for a sufficiently advanced technological civilization. He assumes that there's about 1 million technological civilizations in our galaxy at any time, considering our galaxy has around 200, 400 billion stars or so. And he devises estimates of the frequency with which a given planet in the solar system would be visited if these 1 million civilizations were just sending out interstellar spacecraft or probes at random in all directions.
Like through our atlas, potentially?
Like through our atlas, potentially. Yes, very
Potentially,
much
yes.
so. Yeah. And he comes up with an estimate of one visitation. Each planet, on average, would have one visitation by a technologically advanced civilization, extraterrestrial civilization, every 100,000 years.
Wow.
And so on that basis, he concludes the following. The statistics presented earlier in this paper suggest that the Earth has been visited by various galactic civilizations many times, possibly 10,000 times during geological time. What geological time means is, for example, 1 billion years or more. So if Earth was visited once every 100,000 years, then in 1 billion years, you would have 10,000 visitations, because you just simply divide those numbers. And he says it's not out of the question that artifacts of these visits still exist, or even that some kind of base is maintained within the solar system to provide continuity for successive expeditions. And he suggests that because of weathering and the possibility of detection and interference by inhabitants of the Earth, it would be preferable not to put the base on Earth, but somewhere else, another planet in the solar system. And here he suggests the moon as a reasonable choice. And he says, like future high-resolution photographic imaging of the moon from space vehicles, particularly of the backside, or now we call it far side, might bear these possibilities in mind.
Back in 1963.
Exactly.
This is
So
what
before
he
we had sent anything.
hypothesized. Wow.
And this,
Visionary.
in fact, yeah, and this is the paper, the original paper, which is on NASA's own technical reports archive, which anyone can download. This is the paper, and this is the abstract where he says an estimate of the number of advanced technical civilizations on planets of other stars depends on our knowledge of the rate of star formation. And he goes on and he says the estimates of the present paper lead to 10 to the 6 or 1 million extant, meaning currently existing advanced technical civilizations in our galaxy, the most probable distance being several hundred light years from us. And yeah, he says, as I mentioned already, that if each such advanced civilization launches one interstellar vehicle per year, then average time interval between samplings of an average star would be 100,000 years, 10 to the 5 years. That between sampling of a planetary system with intelligent life would be 10,000 years, and that between sampling of another advanced civilization would be 10 to the 3. So it follows that there is a statistical likelihood that Earth was visited by an advanced ET civilization at least once during historical times. And what's very interesting is that in this paper, although he says there are serious technical difficulties in demonstrating such a contact by ancient writings and iconography alone, later on in the paper, he actually says he thinks this is worth, it's worth looking into the like historical and anthropological files of human history to see if there are any myths about, say, beings coming from the sky that could be maybe perhaps interpreted as evidence of a past ET civilization. Let me see if I can find. Yeah, so he says. He says there are other legends which more nearly satisfy foregoing contact criterion, which deserve serious study in the present context. As one example, we may mention the Babylonian account of the origin of Sumerian civilization by the Apkallu, representatives of an advanced non-human, possibly ET society. So he considers that, and then he also considers this possibility of artifacts being left somewhere in the solar system. So what then? Okay, so that's one consideration. So instead of the moon, we might also consider the possibility of another planet like Mars.
Yes.
Most people don't know that, or maybe not aware that even according to NASA's own studies, this is a relatively recent article, 2022, they estimate that Mars had an Earth-like climate and atmosphere for actually quite a long time. So in this paper, this article, a NASA-funded study concluded that the period when Mars could have supported life like on Earth is much
Yes.
longer than what they had thought previously. So previously, they thought that the late Noachian period from 4.1 to 3.5 billion years ago, so in
Wow.
600 million years, was thought to be habitable on Mars with significant rain near the equator and valley networks and da da da. And the new work extends the potentially habitable period on Mars by about 500 million years into the late Hesperian age. So what this would suggest, if it's true, is that for over 1 billion years, Mars 3 billion years ago, as they say here, this is a
Yes.
conceptual image, reveals what this Valles region might have looked like 3 billion years ago. Any bypassing ET civilization might have said, "Oh, Mars looks like a potentially good place to set something
Habitable.
up,
Yes.
habitable." So that's a possibility as a colony as well. Um, Good. So then the next question is if there was something left on, say, Mars or the moon, how
Yes.
would we recognize it? Well, Sagan actually addressed this question as well in a 1975 paper in the Proceedings of the Royal Society of London. So very prestigious journal. And this is, okay, the abstract. Let me just read you this relevant quote from the article of his. He basically says, let's first imagine a photographic reconnaissance by orbiter spacecraft of the Earth in reflected sunlight as a thought experiment. So he says, we imagine we are geologically competent but have no prior knowledge of the habitability of the Earth. Photography of the Earth at a range of surface resolutions down to 1 kilometers would reveal a great deal that's of geological and meteorological interest, but nothing of biological interest. At 1 kilometer resolution, even with very high contrast, there's no sign of life, intelligent or otherwise, in Washington, London, Paris, Moscow, Peking. But when the resolution is improved to about 100 meters, a few hundred photographs of 10 kilometers by 10 kilometers coverage are adequate to uncover terrestrial civilization. The patterns revealed at 100 meters resolution are the agricultural and urban reworkings of the Earth's surface and rectangular arrays. These patterns would be extremely hard to understand on geological grounds, even on a highly faulted planet. Such rectangular arrays are clearly not a thermodynamic or mechanical equilibrium configuration of a planetary surface, and it's precisely the departure from thermodynamic equilibrium which draws our attention to such photographs.
Yep.
And in
I think
this,
he's referring to geometry and symmetry.
precisely, and in this paper, he actually shows images to illustrate that too. So I just will pick out a couple samples. So here's a couple of examples. Figure 5 This is a photograph of the mouth of the Colorado River, which contains two peculiar features. The first is the bright corkscrew in the upper center, and it's apparently a tidal drainage channel outlined by salt flats. The second is two bright dots at the lower right, which may possibly be boats. And then he notes figure 6. This photograph shows the cities of Dallas and Fort Worth, Texas. Large urban areas such as these and the straight lines of roads are among the major signs of intelligent life on Earth detectable at 100 meters resolution. Like that. And then here's yet another example. A clear example of intelligent life on Earth. A rectangular grid of irrigated fields in the western U.S. is strikingly illustrated in this photograph of the Imperial Valley, Mexicali, part of the Salton Sea, courtesy of NASA. But I suppose he's referring to this.
Max, can you zoom in? Can you zoom in on those photographs a little more, please?
I'm afraid that this is.
There,
let me see if I can
that,
expand this magnification. No, it seems that takes, when I try to zoom in further, it takes me away from the. Okay, so this is as far as I can go in this Sci-Hub website for this particular photograph. Unfortunately, but I suppose if we zoom in further, we'll see these rectangular grid of irrigated fields, or at least here, for example, and here. And he also shows here this photograph covers portions of Arizona and New Mexico, figure 8 here. The bright areas near the center is Wilco Dry Lake and is surrounded by grid pattern of irrigated fields. At the left is another example of intelligent life, atmospheric pollution in the form of a plume from a smoke factory. I assume he's referring to this.
But, it looks like it, yes.
Yeah, and then there's more examples of a dying oasis inundated by dunes in the southern Sahara, figure 9. The mechanical disequilibrium shapes of the palm trees are very evident. And then here, cows casting long shadows indicative of mechanical disequilibrium in California, as we can see in figure 10. So he gives many of these examples of rectangular arrays and so on and so forth to illustrate the point. Now, obviously, on a planet like Mars, on the assumption that there was something left, or there was a base or colony in the past, we wouldn't necessarily expect to see maybe such clear features as we do, say, in satellite imaging of the Earth. We might expect to see something more like this on the left. So this on the left is the ancient Hormesian fortress called Koi Krilgan Kala. I believe it's in Kazakhstan, if I remember correctly. And the image on the left is an aerial image from an airplane of what it looked like before excavation. And as you can see, it looks like it's probably an impact crater of some kind, possibly a natural feature. But you also can tell that it's unusually symmetrically circular and definitely stands out from the surrounding desert-like terrain.
Yes, if I may add, Max.
Yes.
Sagan was speaking of 100-meter resolution. The high-rise camera on board the Mars Reconnaissance Orbit has a resolution of 25 centimeters per pixel. So you can imagine it makes it a lot easier to find potential artificiality on the surface of Mars. There's also the Lunar Reconnaissance Orbiter with an equally good camera on board.
Yep.
And these guys have been surveying Mars and the Moon in ultra-high resolution.
Yes. So that makes it easier for us to implement this program of looking for thermodynamic or mechanical disequilibria on the surfaces of planets that would be indicative of intelligence or of technology compared to the examples Sagan was considering. Yeah.
Yes.
And so, so this example is, I think, a pretty nice one just because it shows that this is like a real world example on Earth of where people saw something from the air and they said, oh, that could be a crater, but maybe it's not. It also looks highly
Mm.
symmetrical. Let's go take a closer look. And then it was excavated in 1956. And then, sure enough, the artificiality and its technological construction was clear as day. So we can
Mm.
apply the same sort of approach to structures on the surface of Mars or the Moon. We look for
Absolutely.
formations that are geologically anomalous, which might be natural, but they might not be. And then we go there and we take a closer look and perhaps someday excavate them.
Mm.
And I thought it might be interesting to see also this table I asked Grok 4 to create, basically scientifically accurate estimates of erosion and degradation for Manhattan's typical buildings and roads on Earth versus Mars. And so it notes key differences and erosive processes on Earth versus Mars. Erosion is much stronger and quicker on Earth because it's a thicker atmosphere and there's water. In addition to air, there's tectonic activity. So there are many more forms of erosion that can occur. There's biological activity, obviously, that's rampant. So the erosion rates are much faster than on Mars. And in the end, it produces two sets of tables between timescales of 1,000 years, 10,000 to 100,000 to 1 million to 100 million to 1 billion years. And I think it's very useful to see this because if we are considering the possibility of visitations potentially a billion years ago or more, or
Mm.
somewhere in between, then we ought to expect eroded structures or remnants. And this table tells us what we might expect to see if, for example, roads of some kind were built, say, on the surface of Mars. So in this case, at 1,000 years, the roads would show minor pitting and abrasion, dust accumulation in certain spots, but they would still be completely recognizable. On the other hand, if you go over to 1 billion years, road remnants persist as very faint linear topographic anomalies or abraded traces with greater cumulative modification, still geologically detectable as anomalous linear features, though more subdued by episodic dune mantling deflation. And it says something similar for the timescale of 100 million years of erosion. Road remnants persist as subtle linear ridges, depressions with moderate abrasion, still detectable as artificial linear features geologically in orbit, and yeah, so on and so forth. And for buildings, it also notes that if we go, for example, to 1 billion years of erosion, structures largely would be intact with a tenth of a meter to 10 meters total abrasion. So heavily pitted, rounded edges, surfaces, possible dune burial or deflation in places, excavatable as clear artificial ruins. And again, this is all based on scientifically well-established erosion rates on Mars versus, say, Earth, and the different atmospheric composition of
Mm.
Mars as compared to Earth. And so bottom line is that we should expect to see not perfectly pristine, blatantly, obviously artificial structures, but eroded and pitted
Mm.
and maybe, geologically structures that look like they could be geological anomalies. Okay,
Yes, and
so
that's exactly
yeah,
what we find on Mars, and specifically Mars, and then maybe on the Moon as well. There's some really odd structures
yes,
there too. But yeah,
precisely.
that's a good table. And what you explained there,
Yeah,
I've seen specifically in a huge pyramid that I found on Mars with rounded
yes,
corners, etc. Yeah, that's exactly a
yeah.
good explanation of why it looks like that. It's quite amazing that Grok would spit out a table like that.
Yeah, and Grok
It
will do
doesn't just
this.
say to you,
Google
no, it's not
AI.
possible. Mars doesn't have
Yeah,
anything on it. It actually gives you a breakdown, which is incredible.
yeah. Yeah, if you ask it in a certain way, in this case, make a scientifically accurate table showing how buildings and roads in Manhattan would look like on Earth and Mars after time scales of this. Be as
Mm.
scientifically accurate as possible, taking into account different items. That's how I posed the question. I've also done this with Google AI and ChatGPT, and it produces more or less the same table with more or less the same uh,
Fascinating.
predictions.
Yes,
Yeah. And
that's fascinating.
there's also a whole field in geology of making predictions or extrapolations of what, for example, the pyramids at Giza would look like um,
Mm.
over thousands or millions of years of erosion. So there's actually like a literature on this of what would man-made structures on Earth or archaeologically historical structures look like via erosion on Earth after like certain periods of time. So this is
Mm.
not just wild speculation; it's actually scientifically informed. Rock is not just making this up out of nothing, and it can be backed up by actual geological literature, scientific literature. And so, okay, so with that background in place, now I would like to introduce Mark Carlatto's approach, which is in this spirit to what he calls planetary SETI, or planetary search for extraterrestrial intelligence. And here he says in this blog article of his, um, he basically was motivated to develop an algorithm that could look for potentially artificial structures on the surface of a planet, um, inspired by the discovery of the face on Mars and the question of whether or not it was a natural formation or not, and how you could discern that by, say, objective methods that cannot be sort of accused of being purely subjective validation or pareidolia or some kind or another. And so he notes that in the mid 1980s, we began a series of research projects at his company, the Analytical Sciences Corporation, that he worked at, to develop algorithms for finding man-made objects in imagery, objects like military vehicles, ships at sea, etc. And inspired by recent advances in computer graphics that used fractals to generate photorealistic natural backgrounds for scenes in movies like Star Trek II, one of his colleagues at the Analytical Sciences Corporation, Michael Stein, came up with the idea of reversing the process. So, in other words, using fractals to analyze images. And he notes that fractals are phenomena exhibiting the property of being self-similar, that a part of a fractal resembles the whole. So the branches of a tree, the shapes of clouds, and the structures of terrain surfaces are examples of fractals in nature. This is from Star Trek II, the movie, basically a planet made out of fractals, uh, water, and I guess mountains and land, and then the space above. And he used this algorithmic approach
And this is an
to,
algorithm that was
yeah.
developed before AI was a thing.
Oh yes, way before. So in the '80s,
Yes.
this was developed, and
Mm.
it can be merged with AI, which I think is
Yes.
a logical thing to do for planetary SETI research nowadays.
But even back
But
then,
yeah,
when it
yeah,
was developed in the 80s, say 90s, they identified artificiality in structures, and it wasn't using any AI or large large language models or anything like that. So this
that's correct.
algorithm is based on mathematics.
Exactly. There's a
Yes.
mathematical model of fractal terrain or
Mm.
background, and then a deviation is calculated from that mathematical fractal model.
Mm.
And the greater the deviation in a certain image, like for example, in this image on the left of an airport showing the roads, the airplane here, and buildings and other vehicles, the deviations from the fractal model are modeled as brightness changes. So the greater the
Mm.
deviation, the brighter. So in other words,
Oh,
the more
yes.
likely to be artificial is the object in the image. So in this
Specifically the
case,
plane, yes. Look at that.
yeah, very, very bright, the brightest in this entire image. Obviously, the roads also are appearing bright, and so are the little buildings and trucks here. But the grass, for example, does not appear nearly as bright, or it's just
Mm.
dark altogether. So that sort of illustrates as one example of how it works. And Carlatto and Stein applied this methodology, the fractal algorithm, to the 35th orbit Viking, a frame of the Viking probe that took the original images of the face on Mars. And their findings on this analysis were published in 1990 by the British Interplanetary Society. So it was taken seriously at the time.
No,
Here's an example.
it's a
Yeah,
credible method of determining the nature of an object.
absolutely. It's very
Yeah.
logical. And yes, it's not perfect, but no
Yeah.
method is going to be perfect.
Just
And
look
it
at
does, yeah,
that bright spot where the face is.
yeah, this is the
So
face. That's the bright spot. Yeah,
clearly, there's some symmetry and geometry to that face. Look at the
yes. And
positive response.
yeah. And this algorithm is not somehow artificially finely tuned to a particular image to produce a desired result. It's one model, one fractal model, and that same model and the method of calculating deviations from it
Yes.
for objects in an image is applied to every single image in precisely the same way. So there's no fine tuning here.
No, there's no bias.
Right. Now, the method is a bit sensitive to something like the sun angle. So the lower the sun angle, so in other words, the lower the sun is above the horizon, the better the algorithm works in identifying truly artificial structures.
Contrast.
Precisely.
In the highlights and shadows, there's a better contrast.
Yes.
It works better in highly contrasted images, basically, as well.
Exactly. And in this case, this original Viking frame 35A72 on the left was taken when the sun was only about 9 or 10 degrees above the horizon.
Yes,
so a very low sun
angle. The long shadow that's being cast.
Yeah, exactly. This conical shadow. And there was a second Viking frame taken months later of face, or the Cydonia area with the face, but the sun angle was considerably higher. It was, if I remember, it was something like 35 degrees or something like that, or 25 degrees above the horizon. And this is the second image that was taken here on the left, set from frame 70A13. The face still is bright, anomalously bright, compared to the background, but it's not as bright as it was when the sun angle was lower.
Yes, because the highlights and shadows aren't as well, they're not defining the structure so well, yes.
Yeah, precisely. And you see maybe some other things like this depression or crater is brighter, but when you go to the lower sun angle, it doesn't, well, in this case, it's not actually in the image, but other structures don't appear nearly as bright. Like this, for example, here, this doesn't appear nearly as bright. One thing that's important to note is that Carlatto and Stein found in their analysis application of this methodology to various earthbound cases that the fractal algorithm was actually more accurate when the sun angle was lower, and genuinely artificial structures showed a stronger response at lower sun angle, whereas spuriously artificial structures showed a stronger response at higher sun angles, and then they produced weaker responses at lower sun angles, precisely as we see in this image. So here he's noting, here he talks about it, only under certain conditions are images of fractals also fractal, and this depends on the sun angle. He also says he sent a copy of his paper to Carl Sagan, and in return, Sagan sent a copy of a paper he had written on the method for searching for extraterrestrial intelligence by detecting deviations from black body radiation curves, which is conceptually very similar to the approach that Carlatto and Stein developed with fractals. And that is, in fact, also discussed in the Sagan paper here. He discusses the method of black body deviations from black body radiation curves in this very paper too, as one of the other methods of identifying the disequilibria, for example, on a planet's surface. So Sagan clearly recognized a commonality conceptually with his criterion in his 1975 paper, identifying deviations from equilibrium. In this case, equilibrium is modeled as a fractal model. So deviations from equilibria in this case means deviations from the fractal model of the background, so to speak.
So I guess we could also say then that this tool that they were using isn't perfect. It does have its criteria. It can be used under these and these circumstances. So it's a tool that we can use. It's not perfect, but it's a tool that we can use as long as we know that certain criteria have been met.
Precisely.
So that makes total sense. Why not?
Yeah. And he's also developed a related algorithm, this one inspired by how human vision systems work. He calls it a biologically inspired algorithm that detects man-made objects as deviations from a statistical model of the image brightness background. So he calls this a biologically inspired or a target screener or bits algorithm. And this is the publication describing how that target screener algorithm works. And he notes that when applied to various satellite image sets of objects on Earth, 100 ground truth images taken under different operating conditions on Earth, the method was about 80% accurate at identifying the artificial structures genuinely.
And that's amazing.
Yeah.
Given that there's no AI involved.
Right. There's no AI involved. It's just this algorithm that captures true general features of artificial structures.
80%, that's pretty good.
Yeah, and then so here he applies that newer algorithm to the face.
Now look at that.
A more recent image of the face, and it obviously is
a bright spot.
Anomalously bright spots, exactly. This is an image from the Mars Global Surveyor image probe in, I think 1998 or so. This is a high sun angle image, but nonetheless it picks it out. And so his point is that, we have these methods that can implement Sagan's general idea, and it works to a high degree of reliability. And while we're talking about Sagan, it's interesting to note maybe some more correspondences between Sagan and Carlatto about the face on Mars. Many people don't know this, but so Sagan wrote this 1985 article in Parade magazine where he ridiculed and made fun of people who were thinking that the face on Mars might be an artificial landform. And then, but that stands in contrast to his 1963 published paper that we saw earlier, where he suggested that Earth could have been visited many, many times. And one has to wonder what happened to Carl Sagan between 1963 and 1985, that he became so dismissive of considering the possibility of, say, the face as being artificial.
No, and then, he was such a visionary in the 60s. What happened from the 60s to the 80s?
Yeah. Carlatto speculates that as his reputation as an expert in his field became greater and he became a spokesperson for the mainstream scientific community, he became more careful about what he said publicly, because in private, at least, in correspondence with Carlatto about his various analyses of the face on Mars, he was actually much more receptive. Here's one of Sagan's original letters to Carlatto, which Carlatto published on his blog. Many thanks for your letter, an interesting enclosure. We also have been working on some approaches to planetary photoclinometry. In other words, methods of looking for modeling objects on the surface of a planet with contrast and shapes and shading, lighting. And he says, I'm enclosing an abstract of some of the work we're doing. And I certainly agree that Jeffrey Soffin's trick of lighting offhand remark is an error. So here Sagan is referring to Gerald Soffin, who was the head of the Viking mission, which took the original images of the face on Mars, who said that, oh, the face on Mars is just a trick of light and shadow. Isn't it funny what a trick of lighting can do to make you think that there's something like a face on the surface? And here Sagan is saying that I agree that his comment was incorrect. That is, the impression of the face on Mars persists over a variation of all three photometric angles. Your key result, it seems to me, is figure 4, which to me shows a hint in the face. Why not? But then he says, I hope we can have the opportunity to discuss this issue more sometime within the next few months. Why would Carl Sagan spend time on this? Yeah.
I guess he had a public face, and he didn't want his peer pressure. He didn't want things to come down on him like a ton of bricks. So, yeah, I understand why I might have done that, yes. So he wasn't under pressure from the agencies to keep quiet or to follow a certain narrative. You know, like, when was the Brookings report done? 1959? And the Space Act followed that? I don't think, do you think he was subject to those two papers?
Well,
I don't know.
Brookings was, the Space Act was passed in 1958. That established NASA, and then the Brookings report was commissioned in 1959 and completed in 1960. So both of these came well before Sagan's work.
Yes, so he wasn't subjected to that by the looks of it in the beginning.
At least in the beginning. Perhaps there are some suggestions to the contrary. For example, Richard C. Hoagland has told me personally that, well, I don't know if this is true or not, that Sagan was an intelligence officer or worked for certain intelligence agencies. So he had an affiliation there, and that what Sagan told him in sort of a private exchange is different from what he would say in public about, for example, the face on Mars or the question of Cydonia landforms being artificial or not. So maybe there was some sort of a political and governmental pressure on him to not say something, but I can't verify that independently. What does seem clear, though, is that he continued to show interest, at least to Carlatto, and he even used some of Carlatto's images of the face in his one of his later books. Yeah, actually, even a more recent book than that, apparently. He used Carlatto's work, and here in 1990, he says, thanks for your recent letter, reprints, and he asks for permission to use some of the images that Carlatto had developed, if I can see correctly. Yeah, here. For a forthcoming book, I would like to reproduce some of your work on the face. In particular, I wonder if I might have glossy copies of your permission to reproduce your images from your article with Michael Stein and give you full citation. So he took this work of theirs quite seriously, obviously, and he says, in a discussion of reasons for exploring Mars, I take a, I think, fair but skeptical look at the face on Mars. And it's in that context I want to show a few of your image processing results. And it's interesting in this little clip about from Cosmos, Sagan says here, maybe I can play it. He says, if we're going to Mars, we should take a look.
Okay, there's no audio, Max.
Oh, okay. So probably the audio doesn't connect, but here he basically says that if we're going to go to the face, if we're going to go to Mars, we might as well take a look at the face itself. So in other words, if we're going to do manned missions, yes. So here he shows the Cydonia, the face on Mars, courtesy of Mark J. Carlatto. This is Carlatto's, and he gives credit to him in the caption. And this is, some even think we should investigate an enigmatic landforms like the face on Mars. He's talking about the blocky mesas that are sculpted, and then a remarkable diverse group of American leaders have endorsed the Mars goal. And yeah, bottom line is he says in this, which anyone can watch, that we might as well take a look at the face. So he was, in the
Sure,
end,
yeah.
in favor of actually studying it in a serious way. And so,
He was a skeptic, sort of. You could say he was
sort
a
of,
skeptic, but he was
yes,
open to the idea.
yes,
Yeah,
very much so. And
very logical. Mm.
yeah, and maybe to kind of reinforce the point of just how anomalous the face on Mars is, um, in a more quantitative way, according to the algorithms used by Carlatto and Stein. Um, there's a book that was published in 1993 called the McDaniel Report by philosopher, professor of philosophy Stanley V. McDaniel. He's deceased, but he wrote this very detailed and impressive study of the face on Mars controversy, the Cydonia controversy in 1993, and NASA's reluctance to take these questions seriously.
Mm.
And he discusses Carlatto's work on page, I believe it's 48 of the book. So this will come up in a moment. And one of the things that he notes, yeah, fractal analysis, he notes is that not only did they apply the fractal analysis to a certain set of images covering an area of approximately 3,000 square kilometers, including the face, and found that the
Mm.
face was far and away the least fractal of these images. They
So
also
they
applied,
viewed it
yeah,
in a bigger picture,
precisely.
and it
And
still
not,
identified it.
yes, and
Well,
not
there you
only in a
go. Yeah.
3,000 square kilometer area, they applied it to a 15,000 square kilometer coverage area of
Wow.
Viking imagery, and the model fit error for the face averaged 2.65 times, so almost 3 times greater than for the strongest detections in all frames. So the bottom line is that the face on Mars was far and away, significantly, the least fractal object in a 15,000 square kilometer terrain of the Martian surface in Cydonia,
Mm.
according to this algorithm. And there's even a nice chart that illustrates this that Carlatto developed. So that's the face. And then this is the chart.
Yes.
This shows the number of pixels in a given image. The surface area covered here is 3,000 square kilometers. 1.2 million pixels were analyzed by the fractal algorithm. And in this image, you find that most of the objects in Cydonia or areas in Cydonia are in this black area here, the surface area black, except for two objects. One is called the fort, which we saw in the previous images, and the
Mm.
other is the face. The face is far and away the least fractal, even compared to the fort. And here in the caption, they say the face shows the highest probability of artificial origin with a model fit error of 75. The face and the fort comprise so few pixels in relation to the total measured area that they appear to be located on the zero line at the top of this small chart. If the chart were 91 feet long vertically, the position of the fort would be about 2 inches from the top, and the face would be about 1/6 of an inch from the top. So that gives a more
Mm.
precise and quantitative, I guess, understanding of just how anomalous the face is compared,
Yes,
according to
I'm
the
glad they
algorithm.
mentioned the fort as well. That's good. I was
Yeah.
going to ask you, what about the surrounding
Yes.
structures? But yeah, they covered that too, which is awesome. And it
Yeah.
falls within the anomalous area of that chart.
Precisely.
That's awesome.
And,
Yes.
and it's funny that, in contrast, Michael Malin, the principal investigator of the Mars Observer camera, and also basically all the HiRISE camera that is presently orbiting Mars, and also the Lunar Reconnaissance Orbiter. So he has somehow a monopoly on most of NASA's Mars imaging and lunar imaging. He said of the face on Mars back in the 90s, it's simply a funny looking hill, and there is nothing unusual about it. And he
Mm.
totally mischaracterized how the fractal analysis method actually works. Um, and never really acknowledged these results.
Yeah, it
Interestingly
sounds
enough,
like
when NASA,
he discounted all that work
or
in one
he
statement. He just
deliberately
discounted all that
mischaracterized
work.
it. Yeah, and NASA was actually offered the software, the fractal algorithm software, to analyze the entirety of the Viking images of the Martian surface, and NASA at the time apparently declined the offer. So there was an opportunity to do a more thorough, comprehensive analysis based on fractals in the early 90s, and that was never done. So that's an unfortunate thing, but clearly there is something here. And for what it's worth, I personally managed to develop a Python script that implements a sort of rougher version of the algorithm used by Carlatto and Stein.
Yeah,
And
unfortunately, we can't get
yeah,
our hands on that original algorithm.
yeah, it
So,
takes,
yeah,
hopefully we can get it from Carlatto someday. But this isn't this is a crop of one of the original Viking images
yes.
showing the face. This is the face, that's the fort. The sun angle here again is like 9 or 10 degrees, low sun angle. And the script that I managed to devise with the help of Grok produces
It's a
conceptually a
Python
similar.
script, right? Python
It's a,
script.
correct, yes.
So
And so
how did you
yeah,
produce this Python script? You fed Grok the paper or the
yes,
calculations that Dr. Mark Carlatto originally published, right?
correct. And I asked it
And,
to write a Python script that accurately implements the algorithm described in the paper, such that I can upload an image and it produces a analyzed image based on the deviations from the fractal model. And
this
this
is
is what it.
the bits version. Is
This is
this
the
the
fractal
bits?
version, actually.
Is that the fractal? Okay. And you
Yes.
can clearly see the face is a bright
Yeah.
spot.
Right.
So
Now
your
there are
script
other. The fort
seems to
is
be working.
also.
Yeah, the pyramid
Yeah. And the
is
pyramids here,
picked up. Yeah.
they respond too. But yeah, the face is clearly responding in a way that say this thing, this thing, this thing, these little hills or knobs are not responding. So conceptually, it makes sense. And also the bits algorithm, I managed to do the same
Oh, yes.
thing and create a Python script for that.
Yeah, there
And
we
it
go. Look at that.
produces a conceptually similar, outcome.
So it can be used with some confidence on other potential structures on the moon and Mars, provided
Precisely.
the criteria of the elevation angle of the sun above the Martian surface is within that working range. So meaning
Yes.
the
And
shadows and the highlights fall within that range for the software to work effectively.
yeah, it can be, that's the ideal. So
Yes.
it works best when the sun angles are lowest. It can still
Yes.
work in other cases, but it's not as reliable. But
Yes.
maybe another instance of this, I can show some examples of how the Python script that I used, how it works when it's applied to some satellite images of the Earth, of
Yes.
objects on Earth
Perfect.
too, just so people can see that it's actually working as it's supposed to in at least many key cases. So here people can go to the GeoEye-1 satellite website, which is a publicly accessible archive of satellite images of the Earth by like a company that runs this private satellite system called GeoEye-1. And then they
So
can download images.
this is different to Google Earth. Are
Correct.
these
Yes, this
higher
is.
resolution images?
It seems so, or at least a certain resolution of a certain resolution. This is,
Yes.
I think, in
That's
Hong Kong or
interesting. So
something.
there is a publicly
Yeah.
available alternative.
Yes, absolutely. At least of Earth images, and Yeah, this is the bits algorithm
Interesting.
applied to
Yes.
the satellite GOI-1 image, and as you can see, it produces a strong response where there is this rectilinear grid-like artificially constructed formation, but not for the grass or the water. And I can show a few more examples along these lines. Here
Yes. So
are buildings.
the
Yeah,
brighter the spot, or the brighter the anomaly, the more
yes.
likely it is to be unnatural.
Yes, that's what the algorithm would say. Or, yeah, the more likely it is to be unnatural or anomalous relative to the background terrain. And
Yes.
here's
And there
another
you can
example.
clearly see that. Yes.
Yeah. And these examples, I can keep showing. Here are some pyramids at Giza now and buildings nearby. Now, one thing I should say is that the algorithm is not perfect. So in this case, we know that the pyramids at Giza are artificially constructed, but in this particular case, the bits algorithm does not identify them in the way that they do the rectilinear square-like buildings. So the
Could
more
that be
square-like, or yeah,
Could that be as a result of the angle of the sun? Because I see that the shadows aren't that long,
yeah,
indicating the sun was quite high up in the sky at the time. So
yes.
maybe one with where the sun was at a lower elevation, it might show up a little brighter.
I think that's very plausible. And certainly, as
That
we saw, sensitivity to the sun angle makes a difference. So, yes,
yes, it, it's
I
possible.
absolutely think so. I also did this. I went to the Lunar Reconnaissance Orbiter Quick Map and I took some screenshots or images of the Apollo 11 lunar module on the lunar surface.
Yes, look at that.
That's the module, and you can see its little shadow. And then I applied the bits algorithm to that image to see if it would pick up the lunar module, and sure enough, it does. That's the bright
Mm,
spot right there. And not just that one, but also the Apollo 12 lunar module. It's this
mm.
little black spot here in the image. And sure enough, the algorithm picks it out very clearly as anomalous. And so it works also on lunar imagery. Um, Here, I also tested it to see how it would apply in the case of, say, like a snow-covered terrain or mountains of some kind. Now, here it produces a very bright response, and this is what this is obviously not saying that the snow is artificially constructed, but it is showing that it's anomalous relative to the
In the
background
background.
terrain,
That's right.
right?
You've got to
And
take it in context
exactly.
of
Same with
the
this image.
terrain.
Yes,
Yes, within which, yes, so it needs an element of human interpretation.
absolutely.
So
Yes,
there isn't any AI involved here. So,
correct.
yes.
And so I thought with this background in place, this context in place, I think it's
Mm.
also we can now apply it to some various Martian imagery and kind of get to that perhaps that interesting part.
That's
Maybe what
Atlantis chaos.
yes, what I wanted to do
Look,
is to
it looks so
first
familiar.
yeah. Oh, and just maybe one more thing about the face on Mars. I apologize for jumping around a little
No,
bit
sure.
irregularly here. Um, did you know that there was a 1958 comic book written by Jack Kirby, the guy who created the X-Men and like other major comic characters, called The Face on Mars? And
Even
this is the
before
actual comic,
even before the Viking mission to Mars.
right? Which was in 1976, I believe.
Yeah, so this is a visionary, Jack
Yeah,
Kirby. Wow.
yeah, and so it's well,
I wonder if he
this
remote
article is
viewed.
about.
I
Mhm.
wonder if he sort of remote viewed the face. I don't know if you believe in remote viewing, but
I
the
mean,
government was sponsoring programs to remote view.
right. Right. I mean, I guess it's one possibility. And if nothing else, the thought that there could be monuments left, face-like monuments on another planet, and that might be a way of signaling, oh, there is an intelligence here, is something someone could have anticipated. It's not some out of the blue, implausible thought. It's something that someone could have at least potentially foreseen as a possible way of doing things. Certainly we know of the Sphinx, we know of other face-like landforms that indicate intelligence, technological intervention in otherwise natural landforms on Earth. So this is a logical idea. And, well, it's interesting, he does say that actually that Kirby had served in the US Army in Europe during the 40s and did some intelligence work. And yeah, this article suggests or asks the question, could Kirby have had foreknowledge of the face on Mars and then put it in a comic book in 1950? Now that's, if we
can only speculate.
Right.
But what are the chances? What are the chances of someone imagining that there's a face on Mars?
Yeah, and calling it.
That's amazing.
I agree. But so now I want to come to your work because some of the images that you've highlighted and analyzed and emphasized in your work. One of these is a high-rise image that NASA calls well-preserved polygons, and it was taken in 2020. You've written a very nice article on your blog, Megalithic Mars, about this particular image, and you note that there's a similarity in these images to rice fields and fish farms on Earth. Here you show some examples of rice fields and fish farms on Earth.
Possibly even salt mines.
Or salt mines, yeah.
That's another possibility, yeah.
Right. And
that's only speculation. But there's a resemblance.
Yeah, and one doesn't need an algorithm or AI to see that. We just look at these images, and clearly there's rectilinearity here in geometry. That is precisely the kind of thing that Sagan was talking about. There are mechanical or thermodynamic disequilibria. Yeah. These are all very, I think, compelling, some of the most compelling images. And you have this nice video where you analyze it and you give the original NASA source and so on and so forth. Yeah. And then there's also the Atlantis chaos region, which NASA has referred to as a possible future landing site for Mars.
That was for Perseverance. No.
For Perseverance.
What was the initial? Mars Science Laboratory.
Yeah,
I think they're referring to Curiosity rover.
Yeah, that could
they
well
were
be.
Looking for a site to land the rover, yeah.
Yeah. And here you showed some really beautiful images from this particular Mars photograph of rectilinear.
That looks like a city from space. Imagine.
Absolutely. Or the ruins, right? Certainly.
And everything.
Yeah. And I want the audience to remember what Sagan said in that quote from his 1975 paper. The rectilinear deviations from equilibrium, the rectilinear geometries of structures on the Earth, and he showed images of that on Earth. Note what Grok said about how eroded artificial road structures would look like. Linear, eroded ruins, geologically anomalous. Well, this is precisely what this looks like.
Sorry, Max, to interrupt you. There was also another quote from Carl Sagan where I'm going to paraphrase. If at first you're looking for traces or evidence of intelligent life, look for the geometry and symmetry of their structures. Something like that. Paraphrasing.
Yes. I believe that was
Cosmos as well.
Yes.
Yes. So there you showed us some examples of same structures here on Earth.
Right. These are Western Sardinia, Turkey, Troy, Turkey.
Yes.
And so on and so forth. It's really hard not to see the resemblance to these Martian structures, which are kilometers and length,
Like cities, yeah.
Yeah, small cities potentially, or towns, or maybe farms or fish fields, or yeah, salt mines. All of these are obvious possibilities.
Yeah,
And
look at the rectilinear
yeah, yeah,
of the previous image.
this
The
one,
rectilinear nature of those boxed in areas.
yes, precisely.
Yeah,
And
that one. No, the
yeah,
other one.
there's, let's see, there's this one here, and then there's this
That
one.
one.
Yeah,
You look at that.
yeah,
And clearly those straight lines are casting shadows.
yes,
So they are on top of the surface.
right.
There's many theories that might be mineral veins, and there was
Hmm.
erosion,
Hmm.
and it exposed these mineral veins. But yeah, we got to go there and check these things out to see what they really
Yeah,
are. But that doesn't look like
yeah,
typical mineral veins. They're more random. The lines are more random. Yeah, we've got rectilinearity, whatever you call it,
yeah,
boxed in rectangular areas with intersecting
yes.
lines. A line will just intersect at right angles with another, and it won't continue on the other side. It's like totally random stuff. What the heck's going on here?
Yeah, there's
So what
probably,
did your algorithm, did you apply it to these structures?
yeah, so I applied it to one cropped example. And so I have a
I'd
set of
love to see what
examples
it
here
did
to
with
show.
this.
Oh, I had one more of your examples I also wanted to just quickly highlight before I show those examples of analysis. Renaudot crater imaged in
Yeah,
2014.
the delta-shaped object.
Yes, that and the surround this one here, and
Yes.
these whatever these objects are, and then the surrounding web-like terrain, which in this 2018 article of yours, you also you show these really nice close-ups too
It's
from
almost like a
the
top of a
JP2.
fungus.
Yeah, potentially.
Maybe. We
And
don't
one,
know.
yeah,
It
and
looks
one
like it.
wonders. Yeah, and well, it's hard to understand how this could be a natural dune formation, or the result of ice forming from CO2,
Mm.
because this does not ordinarily form. At least all examples that I've seen of how ice can form from CO2 condensation, or uh, certainly not dunes, do not form patterns like this on Earth, not even remotely. And
Mm. Yeah,
this
NASA
is
suggests that is
genuinely,
because
yeah,
of a heavier material and lighter material, and then the changing directions of the wind,
yes,
and
which
also
is
the strength
completely
of the
ad
wind.
hoc.
It would move the lighter material and then the heavier material, and then make these funny shapes.
Yeah,
I'm not a
and these are,
geologist, so
no,
I don't know how that works. But yeah, anyway,
well,
it's
for what it's
fascinating.
worth, as a physicist, I would say that that sounds like a completely ad hoc, just so story designed to try to explain these types of formations. And it's to the extent that they have any sort of empirical evidence to support it, it's not from Earth, because no natural features remotely like these that are non-biological exist on Earth, and certainly not on this scale. And
Mm.
moreover, maybe at most they have some computer simulation models that show something vaguely along the lines of what their just so ad hoc, hand wavy geological explanation shows. And
Mm.
I would say to the audience, just because a geological explanation is proposed or could be proposed, it doesn't mean it's correct. There's
Mm.
an infinite number of geologically possible explanations of, say, the rectilinear formations or structures on Earth that are actually artificially constructed. you can come up with very ad hoc geological explanations of buildings and roads on Earth, but we know they're not correct because those explanations are highly improbable. Those geological mechanisms and explanations are extremely unlikely to actually form the things that are seen. And so with NASA proposing any geological explanation of something on Mars, we always have to ask, is it plausible, and what is the evidence that supports the explanation? If it's just an ad hoc, just so story, then we have no reason to believe it. And so kind of in that spirit to further...
As I always say, we present the evidence.
Yes.
It is now up to the other party to prove that we're wrong.
Yeah.
If you know what I mean.
And
in court, we've presented the evidence, you could say. This is evidence.
Yes, I would agree.
The other party needs to prove that we're wrong. So the ball's in their court. And it's easy to opt for a natural explanation. But just like I could be wrong, they could be wrong. So what's the alternative? We need to go there, and we need to go and investigate these things to be very sure as to the origins. But this is evidence. It's compelling. And I'd love to see what your script does with this.
Yeah. Yeah, this is just this is a crop of Atlantis chaos. One of the images that we saw that you also showed in your blog article. And here is one of the algorithm comparisons of the original image of that Atlantis chaos crop. And it produces some brightenings, particularly where it's rectilinear. Now, the closer you get in the images to the objects, the better the algorithm generally sort of works. So it's producing a response, but if I were to zoom in more closely and, for example, take maybe a closer crop of, say, this area here, and then apply the algorithm, or say this area here, the algorithm would almost surely produce a stronger result. Here's the other algorithm. So the previous one we saw was the bits algorithm of Carlatto's. The fractal algorithm produces a very strong response already in this image alone. As
even
you can see
with
by
that
the yellow.
washed out image.
Yes.
That photograph was also taken at when the sun was quite high up in the sky, as far as I know. It didn't cast big shadows. If you go to the original NASA page, you can see the, what do they call it, elevation angle above the horizon. There, 43
solar
degrees,
incidence,
you see.
Yeah.
If
47
it was
degrees
down at
above
10,
the horizon. Yeah.
What did Carlatto say? About 10 degrees, eh?
For the face, that produced the strongest response.
So I think if we can find another photograph taken early or late in the afternoon or morning, then it would produce probably a better result. But if you look at the surrounding terrain in your bits analysis, you can see it's identifying the squares and rectangles.
Yes. Those are the least fractal, clearly. Yeah. And here's another color contrast. So you can create different color maps for the fractal algorithm. This is another color map that maybe highlights the particularly least fractal things more effectively with a different color
Very
map.
bright, yeah.
Yeah, very clearly bright. So there's clearly anomalies in this image. We go to Renaudot crater with the triangular anomalous formation and whatever this web-like, fungus-like stuff is.
Yes.
The bits algorithm responds quite strongly to all of that. Interestingly enough, it responds to everything around the triangular formation, but doesn't necessarily pick out the triangular formation.
Just like the pyramid in Egypt.
Yes. Yeah.
That was dark.
Yes. And same with the fractal algorithm here, and the other It's fractal also, but just a different color scheme. It really responds strongly to this area here, which is somewhere around here as well.
So that's
And
where that strange web-like surface feature is.
yeah, right somewhere over here. So if we go back to the original and zoom in here, we have these odd striations that are quite long.
So it's identifying that that could possibly be, well, it is different to the surrounding terrain. That's why it's highlighting it.
Definitely deviant from the fractal model.
Yeah.
And then maybe in this case of the Renaudot crater, it's worth also checking to see what the sun angle was, so that we can see if that's.
I think the sun was quite high up.
Yes, you're right.
41.
49 degrees above the horizon. So that would, I think, do it. So this also would then be good to see if we could find a lower sun angle version of this image.
Absolutely, worth looking into.
Yeah. There is an option to ask HiRise to take certain images. The public can do that. So at some point, I'm going to try that too.
I think given your credentials, you'll be taken a little more seriously than me.
Well,
I think, yeah, if you could put in a request, that would be great.
Well, I mean, yeah, we could both do it and see. Hopefully, they will see. Oh, there's multiple interests.
Jean Ward, independent Mars researcher, is suggesting or asking, is it possible for us to re-image this at this angle?
Yeah.
And who the heck is he?
Well, yeah, let's try it and see. You know, you never know. There might be someone sympathetic inside, like HiRise, the HiRise team.
Well, I'm sure some of these photographs. The guys, there's maybe a couple of people there that released these photographs, just like that. We didn't see anything.
Yep.
No censorship or anything. Not that they censor. I'm not saying NASA censors. But anyway.
That's possible. I mean,
thanks to Evers releasing these photographs. Oh, this is on the moon.
Yeah.
Paracelsus C. Yeah, the megaliths.
Yes, sir.
Or the structures.
The three structures here in the center, and the BITS algorithm does pick them out compared to terrain, and also this bright mound with some interesting geometry or crater, that's also picked out, as is this one right here.
Yes, there's something that's different from the background, yes.
Precisely. And here is actually an image with a lower sun angle. And as you can see, for the lower sun angle image, the algorithm responds better to the monoliths or the megaliths.
Yes.
They produce a stronger response. And the mounds, the two bright mounds, they also still are very strongly responding to the algorithm, which suggests that these are also interesting candidates for something artificial potentially on the moon's surface. And then
I wonder if there's some parameters that can be changed in the algorithm.
Yes.
To make the identification a little more sensitive. Then we can use higher sun angle photographs. I wonder if it's possible.
I've tried
to have a look at that first.
Yeah, I think well, one thing that makes the algorithms more precise is they take certain areas of the image. They take like discrete units of the image as a discrete unit of analysis. The smaller the area in the image itself, then the more precise the analysis can be done. So in the Python source codes, they take these discrete areas, which are they're not the most precise. So ideally, you would analyze each pixel by pixel. But in these Python scripts that I'm using, they take larger areas that include many, many pixels as like a basic unit of analysis. So it's like more coarse-grained. Yeah. it's more
Agreed.
coarse-grained here, and
Yeah.
it's less accurate as a result. So, but I would anticipate that a more fine-grained version of the Python script, which I've tried to develop but I haven't been able to produce, hasn't worked at all. Like I can't even produce an image so far. But if that could be done, then I would expect even better results.
Sure.
And here's the fractal one of this, of the Paracelsus C megaliths. Note that they produce white, the least fractal color, on the two big ones, on this end and this end, where the shadows are located. That white color does not appear really anywhere else in the analyzed image. So that further denotes that the two monolithy structures are the least fractal in this particular image, which is like a few hundred square kilometers.
The two
area.
corners closest to the long shadow.
Right.
So that ends, the lower the sun angle, the better.
Yeah.
The brighter
so that confirms
result you'll get. Yeah, it confirms it there too.
Yes, and then this is a much higher sun angle image of the structures, and as you can see,
it won't
still
work.
some response, but fainter, much fainter.
Yes.
So
makes sense.
So those are some examples, but there are more that I have to show from your work. So what I will do is I will X out all of these to create some space, and then I will open the other file sets of your images. Go to archive 15 and open all these guys. I'll X out the Paracelsus C. Right, okay. This is the image, if I remember correctly.
Yes, that's the one.
Some of it seems like it's gotten a little bit discombobulated, but okay, so this is the boat structure, or the shuttle or boat thing in this Mars image, high-rise image that you sent me, and the fractal algorithm does pick it out here, along with this area here, which I don't know, I haven't looked into, but it picks out definitely the boat area structure. And I think that's a repeat of that. So does the bits algorithm. That's the boat structure in the center. So it's the brightest of all of them, it seems, or except maybe that.
Yes. That's also because the anomalies are small.
Yes.
I think it's only, 18 meters long?
Yes.
That's 38 feet? Off the top of my head, I remember it to be about that size. That's quite small.
And is this the limited resolution of is this the maximum resolution of this particular high-rise image? Do you recall?
Yeah, that's at actual size 1-to-1 scale.
Yeah. Okay.
But in the upscale, that's the upscale I did using deconvolution.
Right.
Yep.
Now the algorithm does produce some response to it, but it's not as, I think, pristine as it would be if we could. Something about the upscaling.
I should have included more of the surrounding terrain, perhaps.
Possibly. The upscaling does affect things, though. It does. Well, the surrounding terrain. I mean, the algorithm does produce a deviation from the background mathematical model. So the background is like a mathematical model of brightness deviations, but it should produce a response. I would expect if we could get a much higher resolution image just from the high-rise camera, something along this scale, then we would see a
Also,
much brighter
the
response
sun
here.
angle for that particular photograph
Yeah,
was also quite high up in the sky.
yeah, you can see the shadow's not that
Yeah,
steep.
it's
So
at
that could,
about 43 to 48 degrees if you're given
yeah,
looking at the length of the shadows.
yeah.
So,
So
but
there's
it
a whole
is
project
picking up,
here of, yeah,
yes, but it is identifying the line.
yes, right here,
Yeah.
precisely.
Obviously,
And
all
yeah,
these will require some human interpretation as well.
absolutely, yes. And
Yeah.
let me show you also this instance of the, I don't know what we call the well-preserved polygons that NASA calls them, that look like fish farms as you
Yes.
analogize them. And so this
Well,
is
yeah.
just the original image at
Okay.
a certain
Actual
scale.
size, 1-to-1 scale.
Yeah,
Yeah.
yeah. And then this is the bits algorithm response to that. So this is not upscaled with topaz
No.
gigapixel. It's just the original. And it produces a strong response, obviously, in many areas. The fractal algorithm also produces a very strong response, particularly around here or there, or
Yes.
this area.
Yes.
But then also, obviously, many other
The
areas are picked
lines.
out. Yeah. So both algorithms are clearly seeing the anomalies.
Oh,
This is the
yes. Look at
upscaled, the topaz upscaled version.
that H. Look how well
Yeah.
it's defined.
Yeah. Over here. Yes.
That too, yes.
Yeah. And yeah, the
Yeah,
H.
that one.
Yeah.
Yeah.
And then the other algorithm doesn't produce a great response. But again, I think it's something about deconvolution affects how these scripts function.
Yeah. What
But
deconvolution does is it minimizes noise
Mhm.
and preserves original detail. So
Yeah.
I think if we make the image a little more grainy,
Mhm.
because when you upscale using a deconvolution, you can add grain, noise.
Mhm.
And I think what I should do is try that option,
Mhm.
and then you can have a look at it to see if it's producing better results.
Yeah.
I think we need to add a bit of graininess.
That could well be. That
I
seems
don't
like it's
know. I
worth
don't know the
trying.
specifics of the algorithm. I'm not a. What is it? Calculus? Is it based on
Yeah.
calculus? The algorithm?
Yes. I mean, ultimately, yeah.
Yeah, I think
There's
I remember
algebra and calculus.
the formulas in Mark Carlatto's paper are very
Hmm.
heavily calculus based.
And yeah, and matrix calculus in particular. So
Yes.
it can be done, but I think that's a good suggestion is to add grain
Well,
to
we can
the
try it. We can add
upscaled
a bit of
images and see.
graininess.
Yeah, yeah, that's a good idea.
That's something to investigate.
Definitely.
And also,
And
you
yes,
in the non-upscaled version, you're seeing more of the
yeah,
structure itself. So I don't know if that will affect the algorithm. It shouldn't. I don't know. It's
yeah,
worth investigating. But
yeah,
anyway, yeah, fascinating.
absolutely, absolutely. And I think it's absolutely worthwhile to see if we can get lower sun angle images of these particular sites. And yeah, if the algorithms produce clearly stronger responses in all those cases, now you start to produce, this is like a clear prediction, right? If these are artificial structures and formations, they should produce significantly stronger responses at lower sun
Yes.
angles. And so
So
that's a
this is
testable
another
hypothesis
tool.
scientifically. Yeah.
Yeah, this is another tool in our arsenal
Yeah.
to help validate some anomalies
I
if they
agree.
meet the criteria for the software, the parameters that it works more effectively in. It's
I
very
agree.
interesting.
Yes. And okay, so those are the analyses of the software developed by Carlatto that I prepared. I can also now transition to Phobos and the discussion of Phobos if
Okay.
you feel we have time to do it. And
Now, by saying somebody may have been to Mars before, the moon of Mars, the larger moon, is 4,000 miles above the surface, and it goes around in 7 hours. It's a very likely stopping point to be able to control things on the surface. The photographs that have been taken by other satellites going around Mars exhibit a very strange object on Mars. It's not a face, it is a vertical object, and it casts a shadow. The Canadians in, I think it was maybe '06, did a study of sending a spacecraft, a robot, to this moon of Mars. The Russians have been trying to get their spacecraft for 3 times, and they've all failed. The photographs that we see by the sun casting a shadow and knowing exactly where the sun was at the time the picture was taken, they can measure and come up with a calculation that this object was 90 meters high. Now that's a football field. Now in this study that the Canadians did, all the engineers contributing to the study, they felt that this was sufficiently unusual, so they called it the Monolith, after the 2001 Arthur Clarke's movie where the apes were doing things on the moon, and there was a big object that they couldn't understand, and that was called the Monolith. It's still there. I've seen the pictures of that, and I think it strangely was a natural occurrence. No evidence really one way or the other, but it disturbed people that heard me describe this on C-SPAN quite a few years ago.
Yep.
Remember?
Yep.
All right. Well, now that we're getting a little closer, I changed my story, because we need the support of these people that never seem to have extraordinary evidence. So I'm going to suggest that what it is an antenna for the aliens out there, an invisible race that communicates to Earth and other planets here with some of their people, aliens, and they're invisible. And there's one right over there behind you right now. Now this will create a lot of interest when people, oh, what did Buzz say about this? And they will think about the moon and going to Mars. And we need all sorts of people, because the public needs to support what the nation wants to do.
Well, Buzz Aldrin, look, you can see this crowd out here watching you. I mean, are we spending our NASA dollars as well as we could be, in your view?
We don't have enough dollars from the government in the budget to be able to do what we would really like to do. And sometimes, to make matters worse, the politics may trade things back and forth. I'll vote for you, Bill, and you vote for my bill. And
okay, so that's basically the entirety of that section of where he discusses the Phobos monolith. What did you make of that and what he was saying about it?
Well, what I liked about it was he mentioned the Russians have tried and failed. And we've seen the evidence of that with the Phobos 2 craft incident. Then I don't know, he goes a bit off the rails when he talks about antenna and invisible aliens. But he was just joking there, right? That's how I picked it up.
Yeah,
I interpret it as a joke.
I thought it was probably a joke too, or something
Yeah.
he was suggesting to say to generate interest in the space program and going to Mars for the general
Sure.
public. But it's interesting, this Canadian study that he refers to, that was in 2006, where they called this thing a monolith and all of that. This is all true. I mean, this is the study, actually. It was in 2008. It was called the Prime Mission and Mars Sample Return, Phobos Reconnaissance and International Mars Exploration. The team is a number of prominent people from the Mars Institute, the SETI Institute, and NASA Ames Research Center. And they call it, an international robotic lander mission concept to explore Mars's inner moon Phobos to address the outstanding question of its origin. And it was selected for conceptual study in 2007 by the Canadian Space Agency. Okay, so in this study, they show the Phobos, what we call the Phobos monolith here in figure 2. And they say it's 90 meters. Yes. From the Mars Global Surveyor MOC image in 1998, I believe. And notice they call it a discrete positive relief feature. And they suggest that they say the Prime team selected the boulder shown in figure 2 as a candidate landing site to illustrate the Prime mission's unique targeting capabilities. And they want the lander to land within an arm's length of the feature, the monolith, and expose fresh lithic material using an abrasion tool and conduct in situ compositional analysis. To me, it's interesting that NASA Ames Research Center had a representative, as well as the SETI Institute. Why is the SETI Institute?
So it's for extraterrestrial intelligence.
Right. This is the mainstream organization. And
Buzz was joking about the aliens.
Yeah.
So he might know something that we don't.
Or suggest that maybe there's something maybe about it that strikes these people as possibly artificial in origin.
Yes.
And that's why they want to send something to it and take samples and analyze it at the location of the monolith. And because it's a lot of effort, it would be to send a probe to Phobos and to land at this particular place among all the other places
within
on
arm's
Phobos.
length.
Yeah. That's quite a bit of effort. And look at the whole team, the Prime Mission team.
Yes.
Pascal Lee, he's well known, Mars Institute and NASA, Hildebrand at University of Calgary, many people, York University, Guelph, Winnipeg, NASA, JAXA is involved, the Russians are involved, the UK, Cornell, multiple people from. So, this is, I don't see how this is different from me or you saying we should send a probe to the structures in Paracelsus C and take it out into arm's length and then take samples of them. But certainly, this is precisely what you would do if you thought this was a candidate artificial formation or structure of some kind on the moon of Phobos. So I think that's a very real possibility. And for what it's worth, this is the original image from Malin Space Science Systems. This is the company, the contractor for NASA, run by Michael Malin, the guy who dismissed the face on Mars. But here they say, several large boulders can be seen, including a very large one near the center. That's about 85 meters in diameter, which is about 280 feet. And I actually found also the original image strip from Malin Space Science Systems. So what's interesting is if we go to it, we actually see that there are many monolithy type structures nearby, the main one. So the main one is where is it? That's the main one. But there are others too. There's some here. There's one here. There's one there, there. None are nearly as big as the main one, but there are a
Yes.
number of boulder-like structures on Phobos. And so it could be that there are many of these monolithy structures on it. And then the question is, what are they? I mean, one of the mainstream explanations I've seen from NASA is that it's just some ejected material from Stickney crater that just happened to fall back onto Phobos and then get stuck into, I guess, the surface of Phobos. But I don't know how physically plausible that mechanism is. I've never seen a study trying to assess the plausibility of that explanation. This is another discussion. It was apparently found by someone named A-Frame Palermo. SecretMars.com documents this, Michael J. Craig's website. And there is more to say about it because, let's see. Yeah, there's actually a very detailed, this is NASA's article about it.
Yes, but what's fascinating about it too is that there's no impact crater. It's just there.
It's
on a
it's
flat
just stuck.
surface.
Yeah, so are they implying that, okay, here
It
they
might have been
say
placed
most, yeah, because otherwise they're saying that this is just a piece of ejecta from the largest impact crater on Phobos, Stickney crater, and it just fell back onto Phobos and just got
But
stuck. It didn't bounce, it didn't do anything, it just got stuck there.
Wouldn't it have made a
perfectly.
bit of a depression or left some other marks?
I would think so. That's what I would say.
It's almost as if it's been placed there intentionally.
Yeah, that's what it
Then
looks
there's
like
another
to me
one.
more than anything. Yeah.
Then there might be a
Yeah.
second one, right?
Yes, so this is Phobos imaged by HiRISE years later, not too long later actually, 2008. And if we go to, there are actually a couple of image products in color where we can see it from different shadowing. And to me, it looks like a different monolith, if we can call it that.
And
because
it's smaller.
the surrounding,
I've analyzed it. It's a
Yes.
lot smaller than the other one.
Yes, you've analyzed this and nice video. This is it right here.
I think it's 25 meters wide, whereas the other one
which
is
is
90.
Yeah, but it still is noticeably different in its
There's also
albedo,
no
for example.
impact,
Yeah,
no impact crater, no traces of an impact. Maybe it landed there softly and didn't roll around before it came to a rest. That's why they need to go there and check these things out. Is that mission that you were talking about planned?
Yeah.
So
It
it
was
hasn't been
planned.
cancelled yet, or
It hasn't been actually implemented. By the way,
but it's
one
on
thing
books.
it's on the, or at least it's in the proposals. It's a proposal out there somewhere.
And they are suggesting going to the other one, not this one.
That's right. They're suggesting to go to the bigger one. Well, what is interesting to me about this is that its brightness, its color, its albedo is obviously sharply different from the rest of Phobos. There are smaller things, but that's clearly
comes close to it.
nothing comes
I've
close on this
analysed the
entire
HiRISE
side.
photograph, and there's nothing that comes close to it.
Precisely. So it would be interesting to see the bigger monolith, if it's like on the other side or maybe on the top of this image, and see
in the
what
shadow.
it looks like in color. Like, would it be this bright white thing? Would it have a metallic sheen? What would it? Yeah, and then there is also an Italian group that used shape from shading analysis to illustrate what the larger monolith would look like from a side view. And I think
So
it's
that's
worth.
where you extrapolate the height based on the shadow length and the inclination angle of the sun. I think that's
that
how they do it.
that well they try to infer the not only the height but also the shape from different angles, viewing angles. So even if you're looking straight down, you see the shadowing. If you know the sun angle and the shadowing and approximately the height of the object, you can try to infer what it would look like if you were, say, standing next to it and looking at it from
Yes.
the side.
Max, are you
And
sharing an image? Because I don't see
um,
anything.
at the moment, I'm trying to look up the
Oh,
Italian
okay, there
group's
we go.
image of the Phobos monolith, because they have there's a nice website that shows the shape from shading results. I was hoping I should have prepared that ahead of time,
No problem.
but I should be able to pull it up here. Shape from shading. Yes.
There it is.
Okay. Yeah,
Bottom
this
right.
is it. So
Yep.
this is a top view, and then this is the shape from shading depiction or inference of what it looks like from the side. Looks like triangular-ish in formation.
It does.
Yeah. And okay, that's the original image. And then, yeah, this is also now this goes straight into the Soviet
Yes. Buzz Aldrin
image.
mentioned that they tried and failed.
Right. Precisely. And by the way, I might just mention quickly that there's a very detailed Rockipedia article about the Phobos monolith. So Grok or XAI has created its own version of Wikipedia, which they call Grokpedia. And they use Grok, their AI or LLM, to create articles on various topics. And apparently, one of the topics they've created a detailed article on is the Phobos monolith, or the original one anyway. Apologies. And it's just interesting to note how detailed this article is. Quite a bit of references too. And there's also a Phobos Mars Express shaded relief map, so of the surface of Phobos. So I wonder if this might be worth studying to see if we can find the Phobos monoliths in some detail and see where they are located relative to one another. Jean, are you still? It seems that the audio has.
Rex? Yeah,
Yes,
sorry,
there you go.
I had
Okay.
my audio muted.
Oh,
Can you do me a favor
yes.
and email me the link to this particular page, please? I'd love to have a
The
closer look.
the shaded relief map of the Phobos Mars Express. Yeah, absolutely.
Yeah, I see there's PDS data.
Yes.
Maybe there's a nice high-res photograph I can download and
Here's
analyze.
another. Yeah.
Oh,
This is Phobos Mars Express 12-meter resolution per pixel resolution.
12, 12, 12. Okay, then that one in the
And
high-rise photograph won't show up. It's a little too
yeah,
small. Oh, there's a
yeah.
5 meter. That'll work.
This is from Viking, which is quite interesting.
Wow, Viking.
5 meters.
I
What? So
didn't
that's
know it
strange.
had high-res cameras on board.
I guess they
That
had
is
high
interesting.
res enough. Why is Viking having better resolution than the Phobos Mars Express decades later? Imaging of the surface of Phobos. That's quite interesting. I agree.
Well, maybe it was a little further from the moon.
Maybe.
Maybe the Viking was just a lot closer.
Yeah, maybe by luck or by design.
Yes.
Well, Yeah,
I'd definitely have a look at this. Thanks for sharing
yes,
this with us.
absolutely. Yeah, I will definitely send this to you, and we'll see. And this is Phobos 2 that you've already mentioned, alluded to. The mission that was launched in 1988 by the Soviets, and it failed to do what it was tasked to do. And it's interesting that the explanation here on NASA's website, this website of NASA, is the loss of the Phobos 2 spacecraft while maneuvering in Martian orbit to encounter Phobos was traced to either a failure of the onboard computer or of the radio transmitter, which was already operating on the backup power system.
It's
However,
strange that they didn't mention the
yeah,
artifact that it photographed before it went offline.
yeah, so it's funny because if we go to, can you see these?
Yes.
Yes. So this is an article in UFO Magazine in 1992, which reprints purportedly a top secret infrared photo taken from the Soviets' Phobos 2 probe showing an object approaching Phobos. This is Phobos. The object that's approaching is this. Estimates
It's a
say this
long
object,
needle-like
yeah,
object, and it's
15 and a
massive.
half miles long.
Yes.
The photo was first made public on the 1991 show Larry King Live when UFO researcher director Don Ecker appeared on the show with author Keith Thompson. This photo began story of this photo began in 1988 when the Soviet launched two probes, and then they had a laser on board that they planned to fire at Phobos, and the resultant gases analyzed. All went well until March 25, 1989. According to the Russians, something turned the Soviet probe Phobos 2 into a spinner, so made it spin, and then the
Yeah, like it was
spacecraft
bumped.
disappeared, like it was
It's almost
bumped,
as
right?
if it was nudged.
Yeah. And then according to Zakarian Sitchin in his book Genesis Revisited, the rumor going around was that the Soviet spacecraft had encountered a huge UFO while in orbit. In his book, Sitchin included a photo that the Russians released, which showed a large ellipsis shadow reflected off Mars. Sitchin claims that the few photos Phobos sent back prior to disappearing were never released by the Russians and that they treated the entire matter as above top secret. And on top of that, this Dr. Marina Popovich, the former Soviet test pilot who had made several trips to the U.S. to share her views on the UFO issue, claimed to UFO Magazine in May of 1991 that the incident was discussed by Soviet General Secretary Mikhail Gorbachev and President Bush at the Malta conference. And this photo was given to Dr. Popovich, she says, by Soviet cosmonaut Leonov in 1989 and was reportedly taken by the infrared cameras on board the Phobos 2 spacecraft. So I guess it's unconfirmed that this is the photo, but nobody, it seems, has said that it's fake either. So it's an interesting mystery, and this is Popovich at this conference, I guess, where she holds the photo up to show people in 1989.
She
And on
became
top
a
of
huge UFO advocate. She was a
yeah,
test pilot, a cosmonaut.
yeah, or I heard she was a cosmonaut and trainee, or was backup cosmonaut or something like that. Yeah, but she was obviously in a
She
serious
was a pilot
position.
as well.
Yes,
As far as I know, she
Soviet
was a
pilot.
pilot for the Soviet Union, yeah.
And then,
So
yeah,
that's
and
interesting, huh?
I would
So did
agree.
it happen? Didn't it happen? Who knows?
Well, here's a clip from a really interesting YouTube channel called Eyes on Cinema about the USSR space probe Phobos 2 photographed UFO near Martian moon before losing radio contact. So there's about 2.5 minutes or so before it ends, where it discusses that and it shows Dr. Popovich talking about this incident and showing the photograph. I thought I might play it too, because it's relevant to the topic. So let's see. Let me begin at just the 23-minute mark exactly.
Out of commission.
Okay.
The circumstances in which Phobos 2 was lost suggest that someone might be back on Mars, someone ready to knock out what to them is an alien spacecraft.
In 1989, the sudden disappearance of Phobos 2 had ominous overtones. Now, Russian officials close to the space program feel free to offer their own theories about the satellite's demise.
Phobos 2 was supposed to enter the Martian sky and descend to an altitude of 15 meters. Phobos 2 was sending back pictures, as usual, when suddenly the last picture from Phobos arrived. On that picture, you could see Phobos, the Martian moon, and an oblong-shaped object. The object cast a passing shadow on Mars, and then Phobos 2 disappeared.
Scientists from around the world have studied the last photograph transmitted by Phobos 2. The oblong image shown here has been estimated to be at least 25 kilometers in length, nearly 13 miles long. Many believe that Phobos 2 photographed an immense alien craft. Now, nearly 4 years after the disappearance of Phobos 2, this footage, shot by a Japanese astronomer, may help explain the mystery. The footage shows a moving object, casting a shadow on our own moon's lunar surface. It appears here on American television for the first time.
We have not rejected the possibility that a spacecraft took Phobos 2. There is footage of a craft of a great length that flew over the lunar surface at the speed of over 200 kilometers per second. Can you imagine that? A huge space station moving that fast? I believe this is an immense UFO mothership, which may have taken Phobos 2. It's frightening, in fact. The day before Phobos 2 was launched, the senior designer of the project received a phone call. A still male voice said, "Don't launch Phobos 2, or it will be destroyed by a large saucer." We all got a cold chill from this warning.
Could there be an immense UFO traveling through our solar system, ready to destroy any and all satellites that get too close for comfort? It is indeed a very chilling thought.
So, I mean, I don't know about the lunar example that they discussed, but that was Popovich talking about the image.
Yes. It just puts it in context that there are other moving objects in orbit. That other one was around the moon.
Yeah. And there's also an interesting clip here in this documentary where they talk to the heads of the Soviet Space Agency about the incident, or they ask them questions and they ask, was there an alien spacecraft? Maybe it's interesting to see how they responded to that and then followed up, because it's not just Popovich.
And the same day.
This shadow actually appeared all of a sudden. Why am I calling it a shadow? Because you can see things through it.
So this is an object not suspended above the surface, but actually located on the surface itself?
Yes, of course.
This elliptical shadow, then, is it in Mars' atmosphere or on the planet's surface? Or is it difficult to tell?
One thing is for sure. This something is not positioned horizontally.
Well, to me it looks like a rocket taking off from the surface of Mars and leaving a trail behind. What do you think about that?
Well, if you'd want to fantasize, it could be interpreted that way too. Now we think we ought to look at the real circumstances that have caused that trail, even though they haven't yet been fully clarified. That's more likely to be the shadow of some object, since surface elements can be seen through it.
How long will it take to process all of the information to get more or less objective scientific results, rather than fantastic ones?
Come back in a week.
But 1 week later, no details. 3 weeks later, at a press conference, a scientist of the Soviet Space Research Institute offers this curious, unsolicited statement.
It does take a minimum of precision criteria to obtain on the image these spots, which some would like to call flying saucers, that appeared within the visual field of the infrared range. It must be pointed out that the flying saucer version is not ours. We'd have wanted it to all be that way. Actually, at first we were saying that there was no flying saucer, that surely all that we saw could be explained in understandable, natural and physical terms.
5 months later, in September 1989, British Channel 4 runs a new Phobos mission to Mars.
Last year, the Soviets launched 2 spacecraft to the planet, both named after the Martian moon, Phobos. Their mission was to photograph Mars and land probes on its moon. One was accidentally switched off by a mission operator. But the second reached Mars and transmitted pictures that are still puzzling Soviet scientists. As it swung over the equator, it took pictures from a height of 6,000 kilometers. This is an infrared photograph. It shows differences in temperature. The dark patches are colder. This section covers 600 kilometers. It shows objects down to the size of 2 kilometers. It's the most detailed infrared picture of the planet's surface.
We have some very, very thin lines on the surface of Mars in the infrared, which means heat. It's not visible as heat. You can see it through clouds if you wanted to. These have a resolution, these have a width, I would guess, of 3 or 4 kilometers wide. Now, an answer to the question of what it is, I certainly don't know, and the Russians aren't telling us.
Scientists are also puzzled by this shadow pictured on the surface of Mars by both optical and heat-seeking cameras. They're convinced it's a shadow because they can see objects on the surface beneath. But a shadow of what? Finally, there's the mystery of the vanishing spacecraft. The Russians have yet to release the last picture transmitted by Phobos before it lost contact with ground control. But the Russians have said that it shows an object coming towards the spacecraft, an object which, in their words, should not have been there.
The spacecraft was circling Mars, coming into the same orbit as the moons of Mars. And the last picture, they got halfway through it, and they saw something there which shouldn't be there. Professor Kapitsa makes the joke that it's Martian people.
British scientists will be able to judge for themselves when the Soviets bring their pictures to a conference at Exeter next month. Because, of course, there must be a sensible explanation, mustn't there?
But the Russians brought no pictures to Exeter. So, what about the spacecraft's disappearance?
Yeah, so that to me is an interesting montage.
It is. Now, were those 2 craft related? That long needle-like part that was photographed, was that the shadow it was casting on Mars? Was that a separate incident? I'm not sure.
Yeah, it sounds like they're not sure either at the time, but the insinuation is that there could be a connection because I think they say on the same day that the spacecraft was lost, this shadow was seen on the Mars surface. And so I think there's just very interesting historical research to do here to see if this photograph was ever confirmed by the Soviets and where it was.
I'd love to see the original photographs.
Yeah. And then if it's a feature on the surface of Mars, a shadow that big would be highly anomalous in and of itself, I think. So it would be worthy to look at high-rise photographs of that area, I think. And if there's any infrared imaging of the Martian surface, the rectilinear areas that were shown, to see if they still show up. I'm not aware of any infrared imaging, actually. Do you know if there has been?
What are IRB photographs? IRB. Infrared? Because if you go to a high-rise photograph, to a high-rise page, you've got RGB, IRB, and black and white. Okay, I wonder if IRB is an infrared.
It probably is.
I've never used the IRB photographs, and neither the RGB, because the RGB colors are simulated. I always use the black and white photographs, but I think IRB is infrared.
that sounds plausible to me. Yeah, that could well be. Yeah, I don't know what that. Okay, well, I assume it's probably infrared or having to do with that. So yeah, there's some interesting, I guess, analysis that could be done here in connection to that. I mean, obviously, whatever, if there was some sort of a spacecraft that knocked Phobos 2 off its course or whatever, or caused it to spin or destroyed it, it seems it didn't come back for the Mars Global Surveyor or the orbiters, or maybe it's. I wonder why that is. Like, is it because this Phobos 2 is trying to shoot a laser at Phobos?
I don't know.
Or who knows
That's
why?
intriguing. Yes.
Yeah.
So it as a threat. I don't know.
Yeah. I don't know either, but yeah, there's some interesting research to do there, and I agree. So, and yeah, this is the Viking image of Phobos. Quite interesting. And then we have this Prime mission that's still in the works, and these multiple monoliths on Phobos itself.
Yeah,
and clearly
it would
some
appear
interest
there
by.
are two huge monoliths.
Yes.
That's interesting.
So,
yes.
yeah. Well, so these are the main materials I had prepared for the meeting. I do have the STS-48 footage
Yes,
and
let's
the
get to some
STS-80 as well.
UFO footage.
Okay.
Because in the age of disclosure, I think this should be released as
I would
anomaly.
agree.
But I think NASA's calling it ice particles moving around due to the thrusters on board the shuttles. But let's have a look at the footage so that we can decide for ourselves.
Yes.
I find this fascinating.
Yeah, I agree. Let me just X out some tabs here to just make things run a little bit more smoothly. Okay, so this is a videotaped copy of STS-48. Essentially, the shuttle is payload bay is open, and the camera is pointing out of the payload bay towards the limb of the atmospheric limb of the Earth. And this is the horizon just below it, which is barely visible in the video. And these lights below are city lights, or sometimes thunderstorm clouds as well. So I will play this. You can see a little thunderstorm cloud there. This is a marker, or like a Rizzo marker, it seems, on the footage. These are city lights. Again, thunderstorm clouds. This is the horizon just below the air glow, which is the top of the atmosphere edge. And these are our stars. And as the shuttle is orbiting, you can see that the stars gradually fall below the limb of the atmosphere. This is a 5 minutes, 39-second video clip. What I'll do is, apologies, it seems like it's freezing. What I will do is, I'll let it run a little bit. I have to just X out from a couple more things, a couple more items. Apologies for that.
Okey-doke. I'll edit this part out.
Yeah, it's just some of these tabs take up a lot of space, so I'm trying to close them to speed things up a little. Sorry about that. Okay. I can go back, hopefully. Get a better results. Okay. Now I'm going to fast forward to the point where the main UAP appears. Okay. So somewhere here, right around here, you're going to see it pop up.
The top third in the middle.
Yeah. Where my cursor is located, it's any second now it should pop up. And then it's
Discovery Houston for JO.
Yeah. Sorry, it seems that the memory is not.
Morning, JO. We predict the maneuver to the supply water dump attitude will take about 15 minutes, and in order to start the dump on time, we'd like for you to do that maneuver now. We need it to prevent contamination.
Okay, I understand you want us to start the supply water dump now, or at least initiate the maneuver now.
We'd like for you to initiate the maneuver, and then when you get there...
Okay, sorry, it seems that we skipped over it somehow. Why? Okay, it's a little bit earlier, actually. Okay, right there.
Yep.
Right here, it's going to pop up over the horizon, or over the clouds at the horizon. Now it's moving along the limb, and you'll see a flash of light coming from the side here. And then watch how it changes direction. And it brightens as it crosses the limb, and then it dims out as it's flying up into space.
Do you know what into space. To me, that looks like a missile that was launched up towards it from the ground. And this thing identified it and went off. Well, I don't know. It looks very suspicious. Check it out.
Yeah, and then it stopped. And it, you know, in terms of analysis,
it's
of
like
this,
it detected the object.
Yeah, and then it just darted off at a 45-degree angle, roughly into space, from below the atmosphere.
At a rate of knots.
Yeah. Now,
very fast.
Yeah, and there's a lot of analysis that's been done of this particular footage by people like Mark Carlatto, Jack Asher, Richard Hoagland, others since the early 1990s. This was released in 1991. And a couple of things that are, I think, worthy of noting is that, first of all, the object stops for half a second before it darts off. It's the only object in this entire scene that does that. Some of the other objects, they just instantaneously move and change direction. It also, as it's crossing the boundary, this air glow boundary, it brightens and then it dims out as it's moving higher and higher into space. Now, if
almost
this were
as if it fired something to get it going.
Yeah, and
some
also
type of discharge of energy or something.
Well, yeah, and the other thing is in terms of the brightening behavior as it crosses the boundary of the limb and then goes into space and dims out. If this were an ice crystal that was near the space shuttle, like, I don't know, 30 feet away, 100 meters away or whatever, then first of all, you would not expect it to brighten so much as it crosses the limb, and then you would not expect it to dim out as it's moving into space or into the space area past the limb. Its brightness should be, say, effectively constant because it's near the shuttle and it's in orbit reflecting sunlight as an ice crystal would. Yet it is bright, of a certain brightness level, moving along, and then it stops for half a second, crosses here, brightens, and then it dims out as it's moving into space.
Yeah, you'd
That's not
expect an
how an
object
ice crystal would
that's
behave.
moving, and a thruster acting upon it will cause it to do that, not slow down and then dart off in the other direction. I don't know. That's what I think.
Yeah. Yeah, and so the key thing here is it's if you can show that there are other considerations one can make, like if there was something that blew if this were an ice crystal, then it would have to have been blown away by one of the thrusters of the space shuttle.
Mm-hmm.
Well, people have analyzed that question in detail. There are only two types of thrusters on the shuttle, the attitude thruster and the vernier thrusters.
Yes.
And you can show that none of those thrusters are even pointing in the direction of this object, such that when they would fire, they would blow it. And the other point is
off
that
in the distance.
Yeah, it's way off, and also the fact that it stops for half a second before changing direction, that is not something that an ice crystal would do if it was being blown by the gases of, say, the attitude thrusters, which fire for longer than the vernier thrusters. The vernier thrusters only fire for a few milliseconds, and they're much
the
weaker.
Object shooting up from the surface, how can that be related to this thruster firing?
Precisely, and so
it's an independent object, way off somewhere else.
Right, and now if you show that it's way off, if you can show that it is actually at the horizon or at the near the horizon where the cloud layer is that it appeared from, that is sufficient then to show that from the other information in the video, that the distance covered and the time it covers it in implies that its top speed is on the order of hundreds of thousands of miles per hour, and it has accelerations that are on the order of tens of thousands of g-forces or so. And basically those are propulsive capabilities that are vastly beyond anything that human technology, ordinary jet propulsion, rockets, magnetohydrodynamics could accomplish. So basically whatever we're looking at here cannot possibly be man-made, at least according to our conventional understanding of engineering principles.
Yes, these exhibit capabilities that have been described by the UAP people that testify that these things can just dart off at a rate of knots. That's not possible for us.
Yes.
So that is visible here too. We can infer that here too.
Right, and all from the information in this single video, we can infer all of that. And I really like this example because it's something you can deduce for yourself from the available information, and everything hinges on the question of, is this object close to the shuttle, or is it near or at the horizon? If you can answer that one question, you can then show that whatever propulsive capabilities it's showing are beyond human capabilities or not. So there's this one simple question. Yeah, way, way beyond. There is a nice table of this sort that Dr. Jack Cather made in one of his papers to show the propulsive capabilities that would be required depending on its distance from the shuttle. And I would like to show that one table because it's very instructive. Let's see. This is Kasher's 1994 paper or so on this case, and we will get, this is the chart. So he notes that, let us examine the possible accelerations involved. Okay. He says, I've not been able to determine just how far away from the shuttle the main object was, but he uses other arguments to show that it could not be, it had to be a spacecraft. But he says, since the shuttle was about 355 miles above the Earth when the film was taken, the horizon would be slightly more than 1,700 miles away. And then he shows in a table the different velocities and accelerations given the distance from the shuttle. This is the table that he generated. Let me see if I can zoom that in more easily. No? Okay, here.
There we go.
So for 1 mile away from the shuttle, accelerations would be this, final velocity 250 miles per hour.
Okay, miles per hour.
And 10.5 G forces.
Exactly.
10 miles. 10 miles away, 105 G forces, 2,500 miles per hour final velocity. Even this would be far beyond what any human pilot could sustain by ordinary means. So with 100 miles distance, G forces are over 1,000 Gs and 25,000 miles per hour final velocity. And then obviously once you get to 1,000 or 1,700, the accelerations become 10,000 to 18,000 Gs, 250,000 to 430,000 miles per hour final velocity. So
wow.
But although Kasher says we can't deduce the distance, I think we can, and I'm currently working on a paper with him where we revisit the STS-48 case and we make the point that the exact distance can't be known, but it can be inferred that the distance is near the horizon of the main UFO, and so then the latter parts of the chart showing the superhuman, beyond human propulsive capabilities like 100 and more is what has to apply in this case.
Yes, I look forward to seeing that.
Yeah, and so, I think this is one of the most important cases that has been overlooked. And this is the source, MUFON 1994 International Symposium. And then there's a question of what was the bright thing, what was the apparent missile that struck it, and people have speculated that, or have wondered if that could be due to some sort of a projectile weapon or a missile of some kind launched from an Australian, joint U.S.-Australian military base, because the location of the shuttle was around there when that incident, when the footage was taken. So, this is, in my opinion, certainly one of the most compelling cases we still have, despite being in 1991. And the fact that it also appears it pops up out of nowhere.
Yes.
From right around here. People have said, well, maybe it's an ice crystal that comes out of the shadow of the space shuttle. Well, the problem with that is that lots of other objects end up passing through the same area throughout the sequence of the video, and they don't just suddenly disappear, or they don't exhibit any sort of behavior like this. On the other hand, this would make sense if it was coming out of a cloud layer over there. And we saw that there was thunder happening.
That's true.
The clouds, so that would be a more, I think, sensible explanation as to why it just suddenly pops up. Then it came out of the shadow of the space shuttle as an ice crystal.
It does.
Yeah. And so this is one of the other striking cases. And maybe as a last example, I'll show the STS-80 case.
The one with the tadpole.
Yes.
Yeah,
Exactly.
that one's very intriguing.
I agree. Let's see.
playback.
Okay, I'll be coming down on the flight deck and I'll send it to you momentarily.
Copy.
Let's see if I can find that one. And if anyone doubts that these are genuine videos, I can be sure that this information is all publicly available. So NASA agrees and admits that these are actually legitimate videos from their missions. They don't deny that. They don't say these are fake. Nothing of the kind. So that concern can be immediately set aside. Yeah, and then I'll just show your audience in this particular footage. Let's see, hopefully we can get a glimpse of the tadpole UFO case.
Where was this again? This was somewhere in South America.
I believe Puerto Rico island eventually shows up, and that's when the tadpole. Sorry, let's see.
And that object as well, it sort of appears, and then disappears again.
Yeah, and then there are other things streaking across different directions, which I'm not quite sure what those are. These look like thunderclouds, these brightening spots that happen here and there. There. Things streaking across. Yeah, that's another anomaly. This thing just pops up out of nowhere, donut shaped, and then starts moving towards the Earth. And NASA, again,
there's that strange disk or orb, but it's massive.
Looks massive, yeah. And no serious attempt by NASA to explain any of this away. Just the two astronauts on the mission, Jeffrey Musgrave and Tom Jones, said, all we saw was ice crystals. We didn't see anything anomalous, and that was it. There was no other attempt to analyze anything. And
right, and then a bit later on, the tadpole, for a lack of a better word, shoots up.
The tadpole actually it comes up earlier in the footage. I'm looking for another version. Okay, good. This is
there is this from the same mission, STS-80?
Yes, this is both. These are both STS-80s. Yeah, STS-80 footages. So
yes,
from Luna Cognita. There we go.
There we go.
It was. Watch the camera shake and pan the very instant the object appears. Yeah, okay, yeah, that's true. So we'll see it again.
There it goes. Is it possible to slow it down a bit for us, Max? Please?
Absolutely. I think that the person making the footage, he's slowing it down for us. No, okay, he's image stabilizing it. And now he's reducing the playback speed so that we can see it's materialized and then dematerialized or whatever. Let's see. Yeah, that's Puerto Rico Island. It's this array of bright lights and whatever. There you go. Okay.
Wow.
That was useful.
And at what speed? At what speed do they reckon it was moving?
Well, Carlatto estimates in one of his papers on STS-80. So there it is. There's our friend. Here's what I'll do. Actually, I'll run it at like maybe half speed, 50.5x, and then we can see it materialize for ourselves. There we go.
Yeah,
I'll do it again, amazing. But at slower, even slower speed, maybe like 25. Yeah, there we go. Okay.
Is it possible
Keep
to
your
pause
eyes-
on it so that we can
Yes.
see a close?
There we go.
Wow. What the hell is that? I mean, it's an object with this funny tail. Could it be plasma? No, I don't know. It's not smoke.
I don't know.
It's not a contrail.
Yeah, it's not a contrail. It's not an atmospheric
What would
phenomenon.
leave a streak like that?
I have no idea.
Is it blurring on the camera's sensor? No, it gets thinner.
Yeah, it gets thin. And then it appears out of nowhere and it disappears out of nowhere too. And look at the lighting pattern. It's the same with the lights on the surface. But it just appears out of nowhere, right where the lights of Puerto Rico are, and then it disappears as it flies across. Carlatto estimates that this object has a top speed of 500 miles per second, which clocks out, if you calculate it in miles per hour, turns out to be over 1 million miles per hour. So let's see, STS 80, he's analyzed this video as well. Yeah, anomalous space shuttle footage, right. And this is his paper, 2005.
He does have stills of that video footage in his paper too.
He does.
Oh,
this is it. Well, there's a number of anomalies that he shows stills of, and yes, one of them is the tadpole thing
and then the
over here. Yeah, and then the disc, and then another streaking crop. Here's his stills series of the F1 event, he calls it. So it appears here, starting here, grows, wiggles.
Did he ever speculate as to what it might have been?
He didn't do that explicitly. He just estimates the speed of the object. He says figure 6 is a time lapse of the event of the tadpole, so you can see it or whatever this is. And the elapsed time is almost half a second. And then he says the object appears to be moving at a relatively constant speed, assuming it originates at or near the surface of the Earth. The object travels about 200 miles in 0.4 seconds, which yields 500 miles per second, assuming it's moving parallel to the surface. Well, even if that's off by 1/10, even if it's 1/10 of what he estimated, that still is vastly beyond human technological abilities. So there is no way that whatever it's doing.
Max, to me, it looks as if it's coming up from the surface.
That's sort of what it looks like to me too.
And shooting off into space. But it could be that it was in the atmosphere, horizontal to the Earth. I don't know. It's difficult to tell.
Yeah, it's hard to evaluate.
Did it shoot up out of the ocean?
I don't think he's able to determine that specific. The object first appears just off the eastern coast of Puerto Rico. The moon is above and behind the shuttle at this time. Bright diffuse areas are clouds illuminated by moonlight. The darker region between the island and the first cloud bank is either water or a shadowed cloud bank. It's conjectured that the object is either emerging from a cloud bank or rising up out of the water. Yeah, so that's his.
That's what it looks like.
Thought. Yeah, but yeah, again, there's no human technology that could possibly do that. So yeah, that's Puerto Rico, cluster of lights, and yeah, I really hope the Department of War will release this video as well as
this is clearly anomalous.
Yeah, it's hard to understand why it's been ignored all this time or overlooked somehow. And there are other space shuttle videos showing interesting streaks, objects streaking, moving, seemingly into space from Earth. So in the footage as well, and Carlatto analyzes these two. So there's a lot to say here for sure.
Oh, yes.
And I would say these are to my understanding, the two most compelling space shuttle videos. But maybe there are others too.
That was excellent. Thanks for the
Thank you.
hard work. Appreciate it very much. Wow,
thank you for
man.
the platform.
Is there anything
Got a lot going on
that you'd like to conclude with? Anything about this current UAP disclosure that's going on at the moment? Do you think it's going to go further than what we've been dripped and bit fed here and there? Do you think there's something more that they'll be willing to share with us, or do you think it's going to stay with this sort of boring stuff?
I am hopeful that they will release more information. I was told recently by someone who is close to Jared Isaacman and his chief of staff and his associates that while preparing to release files for these Department of War releases, he spent several hours at the U.S. National Archives looking at Apollo images of the moon, looking for examples of possible anomalies, and so he was interested. He even said recently that the Apollo 17 photo of the triangular trio of blue lights and also some Apollo 12 imagery of anomalous blue lights in the lunar sky, that these two instances or sets of photos are the most compelling, in his opinion, of all the Department of War UAP files. So that to me is promising, and I know that he hasn't seen even the best example of that. To me, that's not even the best example of UAP, but in Apollo photography. So I'm hopeful that at some point, if, say, one of us could get in front of him and speak to him and show him, maybe give him a briefing, show him some more examples, not just from the moon, but also Mars, UAPs in space, that he might be intrigued enough to at least open a serious investigation. That's what I'm hoping will happen in the next year or so, and I'm going to do everything I can in my power to make that happen, or to try anyway.
That'd be awesome, Max. Can you imagine if we get the chance to testify about what we found on Mars and on the moon? It would blow people's minds, literally. I hope we get the ear of Congress at least. Maybe a good documentary or two to make people aware of these things, because so many people don't even know about anomalies on the moon, let alone Mars.
Right.
The Phobos incident, no one really knows about that either.
Yeah.
And I was under the impression there was only one monolith on Phobos, but it turns out there's more. There's potentially two or more. So, yeah, Max, we all learn new stuff every day. Thanks, man. I appreciate your efforts.
Well, thank you for the platform. It was an honor, and I'm glad to build on your work too. It's very important.
Thanks very much.
The work you're doing.
Max, we'll do another part. This one's almost 3 hours long. I appreciate your time. I look forward to doing another interview. Thanks very much.
That'd be great. Thanks so much, John.
Cheers, Max.
Cheers.